See if it, you ready for this?
Yeah, go.
It bounces.
It works! Okay, welcome to another episode of TinkMakes. Today, as you saw in the beginning of the video, the intro of the video, we're making this guy. It's a camera arm. We got actually inspired by, there's another YouTuber, Alexander Chappelle. Yeah, I think it was his name.
I believe that was his name.
He made a camera arm, and we have been in this process of improving our equipment,
our tools,
to make these videos better, and thought we could probably do a better job. Well, maybe not a better job, a different approach to making a camera arm. I wouldn't say there is a better or worse version of these, but we wanted to take what we had, design skills, the 3D printers, the approach that is, we hope to be more efficient, and built something that was faster, easier, cheaper to make. Was the goal at the end of this, right? So, yeah, it's here. It took a while. 3 days of filming. This is the third day.
Yeah, 3 days of filming, and during those few days, there was most of it was taken up because of the 3D printing.
Waiting for the prints to be done.
And then afterwards, when we assembled it, we found that some parts might not have fit as well as we thought, so we'll be 3D printing again.
Or we missed features that would otherwise make it better, so we went back and redesigned it.
Yes.
But everything here works.
We're happy with it.
We're super happy with it. This is super smooth. It's super balanced. It's locked right now. And we can probably add more attachments later on as we want. So right now it just has a camera mount for us to put any cameras onto, but Andy and I have already talked about maybe an attachment for a monitor of sorts, so that we can have a bigger monitor for us to monitor our shots. And maybe even a mic mount for any shots that require us to do that. So
just to give you guys a reference, this whole camera arm is actually 7 feet tall. And this arm can extend up to 5 feet. And maybe it might be a little excessive, but I would think if it's there, then maybe one day we'll use it.
Yeah, excessive is an understatement. I mean, you'll see a little later with the B-rolls that we shot, the type of shots that we can now get. I think those are super impressive. But I think, you know what, without further ado, let's just jump right into what it is that
how we made it,
how we made this, and hopefully you guys will join us and get inspired to make either your own version or be interested in, well, a camera arm. So
let's go.
So we 3D designed and printed the parts that will make up our camera arm already, as you can see. It's very simple, just 2 pieces that make up a rectangle. Here we are marking the length of the rods that we need to install the bearings in it, for it to slide smoothly down the aluminum tube.
Okay, so we're just going to install the idler bearings. This is for the counterweight. So the rod spins on this, and these just regular skate bearings go in, and we're just ensuring that they seat flat. Off they go. Okay, so we've got the bearings pushed into this pulley block. Just 2 regular skate bearings that we had laying around. And what's pretty critical is that we want to get this hole on the side to be exactly the hole size of these bearings. And so we've got a chunk of linear shaft that we've got laying around, and an 8mm ream of it. And so we're going to ream these out to exactly 8 mil. This is going to push in and give us a really nice push fit, and hopefully we don't actually have to go and get a bolt with the nut on the other side, but we'll see. So let's just put it together. Now that we've got the top idler pulley installed, holes drilled and tapped in the aluminum profile, we're going to do the same thing for the back end of the aluminum, but this time this is the base. This is what's going to attach the profile over to a bottom plate. If you look closely, it has holes. These holes function the exact same way as the top, so we're going to drill the associated holes, we're going to tap the aluminum, and we're going to install screws on it, and then fasten this. So this will be permanently attached to the profile, and then these large holes on the bottom, those will be bolted onto a piece of wood with wheels so that we can roll this thing around. So let's get to it. Oh wait, and Andy, we need to install the carriage. Otherwise, when this thing goes on, we need to unscrew 14 bolts for it to come off. So let's find the carriage, the cross frame, and install it.
Okay, everyone, as we noticed here when we were cutting this aluminum tube, that this cut actually wasn't very flat. So it's not flush. So when we install it to the plank later, to the wooden board, it won't be sitting flush. So there will be a couple corners here that will be floating up. So we actually will be taking a, what was it, Eugene, a Midas blade?
We're gonna take a miter saw, a miter saw that is got a blade meant for non-ferrous metals. So aluminum is a non-ferrous metal, and we're just gonna chop it flush.
Shave it down, and then make it flush so nothing's floating and it'll sit nicely.
Yeah, we were talking about just moving this thing down so it's sitting somewhere like that. But what we realized is,
you can see the shadows here, that it won't be really sitting onto the wooden board.
Yeah, and because this thing is 7 feet long, we want this thing to be as stable as possible. So a flat edge on the aluminum side so that we can bottom out alongside this bottom flange here. On the wooden plank is probably the way to go. So we're gonna get this thing mounted with all the holes screwed together, and then we're gonna chop that flat once we bring in a miter saw with a blade. And so that should be probably tomorrow sometime. And then this project is 90% complete at that point.
Cool.
Let's get drilling. Okay, so we just drilled the 4 holes on this face of the aluminum tube, the square aluminum tube. We're just gonna set a couple screws so that we can go and do the screws on the underside of the fixture. And the reason why we're doing this is because if we don't register and key this, when we flip it over, what we're gonna get is misalignment. And so just 2 screws in on this side, we'll flip it over, we'll mark it, and then we'll drill and tap it the same way we did it on this side. So off to the races we go then. Okay, so we actually have 8 screws on the base. We didn't do the 4 on each side, so instead of 16, it's just half of that. I think it's stable enough, just based off of what I feel. So,
we'll try
Andy,
it
let's try standing it up. Let's just give it a go and see what happens. There, go for it.
Right here.
Go for it.
This thing's actually really tall.
It's tall. I mean, we know it's 1 foot taller than me, but
Yeah.
I mean, it seems to be pretty stable, short of the fact that it's not actually on a base right now.
Yeah.
Nice.
See, it goes all the way out of frame. Oh no.
Hey, this is gonna give us some pretty good shots. Okay, so we just have a couple of things to finish up here. We have to get the cable that's gonna attach to the front base over the pulley, and we gotta design a counterbalance weight on the inside that will, well, counterbalance to the camera weight. So we have to rig everything up, figure out the weight of our rig, and then we got to finish the base.
The base, yeah.
We got to put some casters and some wheels, so then we can just roll this thing around the warehouse wherever we need our B-rolls and shots. So, cool. I think great progress.
Mm-hmm.
All right. I don't think we need any more than that.
So we finished laser cutting our base.
Yeah, which is this guy here.
Yeah.
It's just 6mm plywood. We laser cut all the holes for this kind of base frame.
And then for the wheels right here, we have 3 of them. Found them lying around the warehouse. So
let's put them together. This should be pretty simple. You know, once we get the wheels in place and the base frame in place, then we can actually stand the camera arm up. And see how it rolls around. We're probably gonna need a counterweight on the bottom of this for the cross arm that comes out. I have a feeling that given the 5-foot length of that arm,
probably need a very heavy.
We'll probably need a counterweight on the other side, just to ensure that it doesn't tip over when we fully extend it. So let's get this assembled and let's stand that guy up and see what happens.
Yeah. Okay.
Cool.
Okay, so now we have all the wheels on. Let's try it out. Something's not right. It's not rolling very smooth. Oh wait, the brake is on. Okay. Okay, this a lot better. Woo! So now we just gotta put this on now.
Okay, so while Andy's installing that, what we have to be careful of is when the arm goes on, the orientation of where we want the front. With the base plate, we have 1 wheel in the back, and so I think this is naturally where we're gonna put the counterweights for the arm extensions, just to the left and the right of this 1 wheel. And so that means the part that is anchored towards Andy right now is going to be our front. So we just have to make sure that we remember that when we actually go and put the vertical arm in. I am absolutely hoping that we don't ever have to take these bolts out ever again.
Well, once you put Loctite, it ain't coming out.
Well, it will still come out. It may be a little bit more difficult.
Now let's flip it and I can tighten it.
You'll need a new, so
wrench.
Maybe this guy here. Give that guy a go. I don't know, is that too big? Perfect.
Okay, so there it is. This is good.
Okay, we've got the base that we anchored. We're now going to install this carriage, this cross carriage, along the tube into the actual base. We've got the actual portion that we need lined up with the pulley on the top, and the only thing we need to worry about now is where the cross arm goes. So this is the cross arm. That's the front facing Andy.
Yes, the 2 wheels.
And so this is the orientation it's got to drop in. So
yeah.
let's do it.
So it should be, wait, no, this is supposed to be turned, right?
Nope, we had it right.
Wait.
Okay. So.
Okay, I got it.
Only thing now, put the screws in. Nice. Hey, it actually, whoa. I almost died. It actually works. Let's screw that in and see what happens.
Yeah.
All right, so we are actually about to install the bolts or the screws into the aluminum housing on the bottom. And we realized that there's gonna be a basket that will run inside the aluminum tubing, and the screws can't actually protrude into the internal space. So these screws are 16 millimeters long. We need 13 millimeter long screws. So our hack is to just put a nut. We're still going to add a washer into this just to give it a little bit more surface area, but this should give us plenty of clearance once it goes in. It won't interfere with the actual counterweight balance of the pulley. So just wanted to really quickly show you guys this because it's going to be pretty important when we actually install it.
Yep. Cool.
Okay, let's go for it. It's
a bit wobbly.
Definitely wobbly. We need to put a bit of weights on the bottom to make it a little bit more stable. But here's the ultimate test, Andy.
So this is like 4 feet.
Let go.
Okay. Okay.
No, it's not.
If we do more,
it's gonna fall for sure. So yeah, that counterweight on the bottom. Oh, I'm out of frame. That counterweight on the bottom, it's gonna be pretty important. Right now, my foot is just holding it down, but here, Andy, let's extend it all the way. Kind of brace it a bit. I'm just gonna let my foot out. Yeah, it's definitely gonna. Yeah, we need a weight. So I think if we limit it to like,
it'll be fine.
4 feet. This is like 3.5. This is about 4. Without the weight of the camera on there, it'll actually probably work. The actual, so we got a portion on the back, the little knob, that's actually holding the weight really, really well.
Yeah.
If we just loosened it, then we get our up and down motion. Just loosen it all the way, Andy. So we've got our vertical, our horizontal movement. I think only thing that we need is to get the counterweight balance wire set up, the camera mount on the front, a cap on the back.
Put some weights on the board as well.
And I think we can call this project done.
Yeah.
Cool. Lock that because this is heavy.
Okay.
Cool. Good. Yeah, I mean, it's mostly here. Let's see how we can pull the pulley system right now.
Yeah.
We're waiting for a couple prints to come off the printers. The camera mounts in the front, again, the little stopper in the back, and then the basket that actually goes inside.
Goes inside, yeah.
Those are being printed right now, so once they're done, we'll be back.
Yep.
Okay. So we decided for the actual pulley system of this camera arm to go with these metal airline cables. We could have gone with string, but we felt that given that we were going to go overboard with 3-inch square aluminum profiles, we may as well just go as industrial as we can go. So 1/16 airline cable, I think we just got these at Home Depot. And then they also have little crimping systems that allow you to crimp them and make little loops. So we'll bring the camera a little closer and you'll see what we're doing with the anchor here. It's just a loop with a crimp, and that's going to anchor and hold the actual carriage plate, carriage housing, so that we can loop it over and then attach it then to the basket that's inside. So we can come a little closer and we'll show you how it's actually done. Okay, so here's the crimping system that these cables are sold with. They're just a little aluminum loop that you pull the cables through, and in our case, we just pulled it both through once. We've got this little anchor piece that we bolted onto the plastic. It has a little, 2 or 3 millimeter slot through it, and that just loops around. When this guy gets crimped down, it's gonna hold super strong, and it's going to allow us to then connect essentially this whole housing to the inside. So we don't have the actual crimper. So these are kind of your super cheap wire crimpers you can get for electronic purposes, and we're just gonna pinch down a couple times and see what happens. If these don't work, then we'll go for something else. And
did it work?
I don't know, let's see. No, it did not. So give me a second, I'll be right back.
Are you sure that will work?
Yeah, this will work.
I feel like you just chopped it. Well, why don't we use the yellow one?
Because the yellow one won't work.
Not this one.
Here,
watch this.
You're
gonna chop it again, bro.
Okay.
Did it work?
I have no idea. Let's see. Yep. That's all that's needed.
So now we're going to be installing the backing plate. This piece is essentially here to prevent this from shooting out if we pull all the way out. So it'll be a stopper right here to keep it from shooting out. So we're just going, this is just a snug press fit into it.
Yeah, it's a wedge fit.
Just like that, and it should be good. Yep.
Okay, so I guess the only thing left now is the counterweight for inside the tube and the bottom of the base.
Yep.
Cool. All right, so we're just on the last portion of the build, which is the little basket that we've made that's going to contain all the weight that's going to hoist the arm or counterbalance the arm that is going across. And we just made a really simple loop with the airline cable. I don't know if you can see it, with a crimp on the side and then just open on the bottom. The box here has a hole that we're going to be threading this thing through and crimping, putting another crimp on the bottom so that this thing gets held by the other end of the wire that's on the carriage. So once we do this, then it's about putting as much weight as we can into this basket. We don't actually know if this basket's large enough. And this idea may totally change if we in fact can balance it. So what we may actually just do is try it out with everything that we've got, and if it doesn't work, then we've got to go for something more heavy duty, so like a block of lead or something like that that we have to find and source. Otherwise, we'll give this a go first. All right, cool, let's get to it. All right, so cool. We've got the basket with the looped strap that we built. This is the other end, crimped the same way, except on the other end, we just have a, I don't know what these are called. Hooks? Open-ended hooks. I mean, the idea is that if we ever need to service this or add weights, it's a little easier to just pull everything out of the tube and hook it on and drop it back in. So let's go and put this inside. So we've pre-measured the length of the wire that's here.
You need a screwdriver?
Yeah, there's a screwdriver right on the stool that I'm standing on, the step ladder that I'm standing on. Oh, well, that works too. And, well, I guess the last thing to do after this is counterbalance it with the weights.
Yes.
And hope that we have weights that are dense enough to meet the rig that we're putting on here, because I think we're going to be looking at around 4 kilos of weight, which will make it work.
Yeah. I hope nothing happens, or it'll be a pain to take things out of the tube.
Yeah, it won't be too bad. Okay, cool. So these are the potential weights we're using. They're linear shafts that we don't use anymore for our printers. They could be damaged, bent, just didn't meet the QC requirements that we needed for the printers that we built. So instead of throwing them away, we're gonna use them for weights. The length does not matter for our purpose, but the weight is gonna be. So we're gonna try and pack it in as dense as we can and, well, see if it works. So let's give it a go. Let's drop it in. We'll be right back. We're gonna go find another bag. Oh, okay, we're a little bent over. Okay, we actually found more rods that were just not good to use. Just want to push it all the way to the bottom. We actually needed 2 more bags of
which
rods.
comes up to 4.8.
No, I think it comes up to.
Oh, did we use 5 bags?
6 bags.
Together? 6 bags together. Okay.
So it's like 6.4 or something like that.
Something like that.
We'll put the proper weight on this, which if you loosen the little screw on the back and we just let it go, it's actually a little bit too weighted inside, but we did that in anticipation of the fact that the camera is going to go on the front portion here. And that camera is about 800 grams, give or take?
Yeah, 800 grams. We measured it earlier.
So we've got a mallet. This mallet is about 600 grams and
we placed it on, it balances completely.
It's actually really nice.
Yeah.
So we can always tune the balance, the counterweight on the inside. So if the camera gets heavier, we put more rods in.
Yeah.
But this system right now is about 6 kgs, 12 pounds, 12 something pounds. And we've got a ball head mount for the camera, and then on top of that, the camera itself. So this weight difference
will probably be
canceled out.
Yeah.
So I'm actually pretty happy with this, Andy. I think given what it is, given the amount of time it took to print this, and the amount of cost we actually spent building this project, I think it was under like $100.
Isn't it under like $50? I mean, no, actually. The
it could
rods. Be. Yeah, I think it's under $100.
You know what? We'll meet you guys back at the bench and we'll kind of go over all the parts and the cost of everything. I'll give you guys a sense of how long it took to print these objects, how long it took to design these objects, and maybe how many failures we had in the process due to yours truly.
Yeah.
So we'll meet you guys back on the bench.
But first, we still gotta install a camera mount, and afterwards we'll also give you some action shots.
B-rolls of what this thing can do for us. So give us a second. Okay, so let's break down the cost a little bit for you guys on the cost of this build and how much we actually spent putting all these together. Keep in mind, we salvaged a whole bunch of stuff that we
didn't
had
have to use at the warehouse anymore.
Yeah, we found, for example, the weights for the rods. Those were a non-cost for us, but it's going to cost you guys something. But overall, we're going to break it down to 2 ways of doing it. What we believe what the retail cost will probably be, and what it actually costed us to do this. Yeah. So
start out with the aluminum tubes. They usually cost what, around $80 to $100?
Yeah, we called around a couple metal shops, and for a 12-foot length of 3-inch extruded aluminum, it was about $80 plus taxes or whatever it is, Canadian.
Yeah.
When we were looking at this, though, we went to Craigslist and we found a couple people selling, I guess, structural beams that they had bought these for at the exact same length. So I think we lucked out.
Yeah.
This costed us $60.
Yeah, so $60 for this length. So you're looking at 7 plus 5.
Yeah, it came as a 12.5 foot. We chopped it down into a 7.5 foot length, and then this guy, the cross arm here is 5.
Yeah.
We may only end up using 4 of it because it's actually really long.
Yeah. NEG keeps arguing with me that we don't need it.
We'll keep it, but we probably won't use it. So moving on to the next object then is all the 3D printed parts. This is PLA. We use PLA. We love using PLA because of its ease of printing. This total was about 50 hours of printing time.
Yes.
In terms of printing time. We split it between 2 machines. We got most of it done in about 2 days worth of time. The big pieces, they're about 8 hours a piece.
And there's 4 pieces of them, so that's around 30 hours.
Yeah, and they're printing at 300 microns. We put the density at about 40%, so they're quite dense as parts. But overall, it took about a spool and a half of material. So
that's around $50 to $60.
Maybe 75, depending. It really depends on the material cost of you guys. For us, it would have cost
We're just basing it on our filament.
Yeah. And then we got miscellaneous stuff. So we can't see it, but the actual tensioning string that's on the back of the
crimps,
the crimps, the swivel arm thing that opens up, that was purchased just from a regular hardware store. That was about $15, give or take.
Yeah.
And then all the bolts and stuff was all accounted for. The one thing that we did not have to pay for that I know is going to be a pretty major cost, though, is going to be the casters, the wheels.
Yeah.
We didn't need to pay for those.
We salvaged that from a crate that we had. It was a
trade show crate.
A trade show crate. And then since we took them off, it didn't cost us anything, but I'm thinking there'll probably be $15 per, at least $15 per.
Yeah, those ones are probably a little bit more expensive. The crate was heavy,
but heavy duty ones.
You can buy casters that cost anywhere between 5 to 15.
Yeah.
So that was not a cost that we had to bear. And then the little bearings. Those regular skate bearings, they're just regular 608Z bearings. We have a total of 34 in there. It costed us nothing because those were bearings that we no longer use in our 3D printers. We have moved into a different type of bearings, and they were just laying around. So I think the typical cost of that in Canada is about $1, but I know you can get them online for way cheaper, like 30 cents each. So there's the cost of that. And I think that's about it. I mean,
that's around $9, I'm guessing.
Yeah, laser cutting the wood. Again,
we have access to one, so that also cut a cost.
You can definitely drill the holes. We just decided to use robotics and machinery to do that because it's easier for us. So laser cutting that, the material was like $2 of wood, and then I think we primered it. So whatever the cost of a primer had, like
$10,
like a third of a bottle, maybe less than that, like a fifth of a bottle, whatever.
If you add everything together, I guess we're sitting a bit shy of $200.
Yeah, $200 of material cost.
Yeah.
I don't know about labor cost. There are trials and fittings.
Yeah.
Redesigning of the actual base that we did that I forgot to do. Like for example, this knob, that was not designed in originally. And so we had printed 2 of these just then to think that we needed one of these or wanted one of these for holding it in place. So those pieces weren't used. R&D time, and then assembly time.
Assembly time, which sometimes we would mess up and things didn't go our way.
But overall, I think cost-wise, $200 can get you this up and running pretty quickly. Even at retail cost of the aluminum extrusion at $80, that's half of the cost of the build. Very close to half the cost of the build. The things that we didn't include was the actual mount, the camera mount for your camera. You can put any camera mount that requires a 3/8 inch thread. There's a hole that is bigger than 3/8 there. And that's your choosing. But I think this whole entire thing was about a day and a half of real just putting it together. We spread it out among like 4 days of doing things here and there. And then reprinting parts was probably where the biggest extra time add was. But $200 all in could get you a camera arm that otherwise would cost
maybe a couple grand.
$10,000, 15. You'll be lucky to find one secondhand for a little less than that. Designing one is simple. We joked about what to do with this. I mean, we're gonna use it for our own purposes, videos for you guys. Up until now, we've had to haul around a tripod, putting it on tables. This thing is taller than I am.
Yes.
And it's gonna make life easier. And we're gonna do just that. We're gonna use it. But we may think about maybe even putting the plans up for people that want them. We don't know what we're gonna do yet, but
if you guys are definitely interested, remember to put it in the comment section, and maybe that'll speed things up for us.
Printing them obviously is not an issue for us. We have a couple banks of 3D printers that we can use that for, and I mean, if there's somebody out there that wants one that don't have access to 3D printers, or if they do have one that wants access to the files, then we'll play with the idea of that, and as long as it doesn't increase additional work for us, all would be possible, right? So, I think this project is a complete project at this point. Oh, one thing. I just looked down. What you guys don't see is weights that we have put on the bottom to make sure that this thing is counterbalanced, so that when the arm extends, it doesn't fall over, right? So, that's fully extended, 5 feet. It's not falling over. So the thing that we did not account for on the bottom is the cinder blocks or the cement blocks that we want to put down there. That's gonna probably add a couple dollars. We just have bags of rods down there right now. When I mean bags, they're probably like 4 kg bags of rods on the other side of it. On the other side where the arm would naturally not extend. So $200, I think would get this thing ready to go for someone. So I think short of that, B-rolls, we've got to capture some B-rolls, and then this video is done. You know, I think it's gonna help us build better content. And well, I'm excited to use it, so I don't have to jump on the tables while behind the cameras and change the way that just our shots look. So,
which was what we were doing before this.
There's a lot of movie magic you guys don't see, and we're trying to make better content for you guys. We're trying to make, we're trying to make things that are, number one, going to help us. But it may help you guys get inspired to make something that is going to be important for you guys. You know, through additive manufacturing technologies, one shape or another. Cool.
So we'll roll the B-rolls, and then we'll catch you guys next time.
Cool. Cheers. They're totally out of frame.
Couldn't see it. It works.
Yeah, it works pretty good.
Wrong side.
The wheel goes on the bottom, bro.
Buddy!